What is the true shape of reality, and would we recognize it if we encountered it? This inquiry forms the basis of a profound and largely unresolved philosophical question. It is a question that transcends conventional scientific investigation, reaching into the domains of ontology, perception, and the limits of cognition itself. Imagine, if it is possible, a spatial reality that extends beyond the three observable dimensions. A structure not characterized by the familiar coordinates of forward and backward, lateral and vertical movement, but rather one in which spatial extension incorporates a direction for which no human language or mental construct presently exists. Human beings are intrinsically confined to three-dimensional spatial perception. All interactions with the physical environment, observation, locomotion, construction, occur within three orthogonal axes: height, width, and depth. These dimensions are not simply descriptors. They are the fundamental parameters of existence as it is subjectively experienced. And yet, both mathematical formalism and certain physical theories propose the plausible existence of additional spatial dimensions. These dimensions are not speculative embellishments, but are treated as integral components within some models of fundamental reality. This presentation does not aim to deliver conclusive answers. Rather, it proposes a disciplined thought experiment. If one were to enter a fourth spatial dimension, what would it feel like, not in terms of measurement or geometry, but as a conscious, lived experience? Throughout the subsequent exploration, this central question will be examined through a progression of theoretical models, cognitive limitations, and paradoxes. No definitive resolution will be offered, for the objective is not to dissolve mystery, but to engage with it more deeply. In doing so, we may approach, though perhaps never fully grasp, the true shape of reality. To engage meaningfully with the notion of a fourth spatial dimension, it is necessary first to establish a conceptual foundation. However, this foundation must be constructed carefully, for excessive simplification risks diminishing the complexity and the mystery of the inquiry itself. Human perception operates within three spatial dimensions, a fact so fundamental that it often escapes conscious consideration. The first dimension is linear, extension along a single axis. The second dimension introduces width, enabling planar surfaces. The third dimension incorporates depth, producing the volumetric spaces in which physical objects and biological organisms exist. These dimensions are not arbitrary constructs, but constitute the structural reality in which matter organizes and events transpire. The notion of additional spatial dimensions, while counterintuitive, arises naturally within certain branches of mathematics and theoretical physics. Higher dimensional spaces can be defined algebraically and are indispensable to various models, including those employed in string theory and multidimensional topology. Yet mathematical definition does not equate to perceptual accessibility. A two-dimensional being, hypothetical but useful for thought experiments, would possess no framework for understanding depth. A three-dimensional sphere passing through such a being's plane would appear not as a sphere, but as a sequence of expanding and contracting circles. This analogy, often referenced in discussions of higher dimensions, serves to illustrate a critical limitation. An entity confined to a given dimensional space lacks the cognitive apparatus to visualize, let alone inhabit, higher dimensional structures. Thus, the core difficulty of conceptualizing the fourth spatial dimension does not reside in the mathematics, which are well established, but in the phenomenological gap between definition and experience. To understand a higher dimension is not merely to calculate its properties, but to imagine, however imperfectly, what it would mean to exist within it. This challenge raises a further philosophical question. Is reality constrained by the limits of human perception, or does it extend indefinitely beyond them? The inquiry remains unresolved. Mathematics suggests possibilities. Cognition imposes boundaries. The subsequent discussion will attempt to navigate these boundaries without collapsing the profound mystery they protect. To postulate an encounter with the fourth spatial dimension requires moving beyond abstract mathematics into the speculative domain of phenomenology, the study of conscious experience. The first and most immediate consequence of such a transition would be the dissolution of all familiar spatial references. In three dimensions, motion is defined by displacement within a triadic coordinate system. Each point in space can be located relative to three orthogonal axes. Movement through this space involves predictable alterations in position along these axes. A passage into a higher dimension, however, would render these coordinates insufficient. The established framework of orientation, upward and downward, forward and backward, lateral movement, would no longer define possible trajectories. Displacement would involve a direction inaccessible to human locomotion and inconceivable to three-dimensional perception. What is commonly described as falling would cease to hold semantic value. Falling, as understood within the terrestrial context, is a vector of motion governed by gravitational attraction along a spatial axis. Absent the familiar three-dimensional field, gravitational effects would either be transformed beyond recognition or rendered entirely irrelevant. The individual, were they to retain continuity of consciousness, would find themselves bereft of any comprehensible sense of direction or movement. Furthermore, the phenomenological texture of the environment would alter fundamentally. Spatial boundaries, as delineated by surfaces, edges, and enclosures, would no longer possess coherence. Objects as conceived in three dimensions would intersect and interact in manners inconsistent with known physical laws. An entity originating in three-dimensional space would not simply translate into the fourth dimension intact. The structural integrity of physical form is predicated upon the stability of three-dimensional spatial relations. Thus, upon transition, the anatomical and material continuity of such an entity would likely be disrupted or radically reconstituted in a manner impossible to model within current scientific paradigms. The implications extend to perceptual modalities as well. Human sensory organs, eyes, ears, skin, are evolutionarily adapted to receive and interpret stimuli originating in three-dimensional environments. A fourth-dimensional context would present no recognizable stimuli for these systems to process. Perception, as biologically and neurologically mediated, would either collapse or adapt in ways that cannot be extrapolated from existing empirical knowledge. The notion of continuity, whether of form, motion, or awareness, would therefore be subject to profound alteration. Any surviving aspect of selfhood would inhabit a state unbounded by prior experiential categories. The transition into a higher dimension, rather than constituting an extension of familiar experience, would precipitate an ontological rupture. The individual would encounter not merely a novel environment, but a fundamentally different order of reality. This order would resist description, not due to insufficient vocabulary, but because it would operate according to principles alien to three-dimensional cognition and conceptualization. The transposition of a biological entity into a higher dimensional space necessarily invokes the question of conscious experience, not in the form of subjective speculation, but as a serious inquiry into the structural dependencies of awareness and identity. Consciousness, as presently understood, emerges from complex neurobiological processes occurring within the human brain. These processes are intrinsically linked to three-dimensional spatial organization. Neural architecture, sensory integration, and motor coordination all presuppose and operate within the framework of three-dimensional space. The translation of an individual into a fourth spatial dimension would therefore not merely reposition the physical organism, but would confront the foundational architecture of consciousness with an environment for which it possesses neither evolutionary precedent nor adaptive strategy. Sensory input channels, visual, auditory, tactile, olfactory, and gustatory, would lack the capacity to interpret stimuli native to a higher dimensional context. Vision depends upon the reception of electromagnetic radiation reflected from three-dimensional surfaces. Audition processes vibrational disturbances in a medium confined to three-dimensional propagation. Even proprioception, the sense of the body's position and movement, is inextricably tied to three-dimensional coordinates. In the absence of comprehensible sensory data, the perceptual field would either collapse or undergo a form of restructuring unaccounted for by current neurological or cognitive science. Such restructuring, if possible, would not constitute an extension of known perceptual experience, but would represent a transformation into an entirely new mode of awareness. Further complicating this prospect is the nature of identity itself. The continuity of self, the sense of personal persistence over time, is contingent upon stable patterns of neural activity and the consistent integration of sensory feedback. Both would be profoundly disrupted, if not rendered obsolete within a higher dimensional environment. Should any aspect of consciousness survive this transition, it would not retain its original form. Memory, recognition, and the coherence of selfhood are constructed within and for a three-dimensional existence. In a fourth-dimensional reality, these constructs would no longer align with the environmental structure or the mode of being required for coherent experience. It is conceivable that what might persist would be an altered form of consciousness, one unrecognizable by three-dimensional standards. This form would not be an evolved adaptation, as biological evolution requires generational progression and environmental consistency. Rather, it would be a contingent manifestation of whatever principles govern awareness in higher dimensional realities. The nature of such awareness cannot be predicted or modeled using existing frameworks. It remains speculative, bounded by the limitations of three-dimensional cognition, attempting to theorize beyond its inherent constraints. Thus, the consideration of consciousness within a fourth spatial dimension transcends biological and neurological inquiry. It enters the realm of theoretical phenomenology and metaphysics, where the familiar metrics of perception and selfhood give way to ontological possibilities that resist empirical validation or complete conceptualization. Within both popular discourse and certain scientific frameworks, time is frequently designated as the fourth dimension. This characterization, while possessing heuristic value, requires careful examination to avoid conflating distinct conceptual categories. In the context of classical mechanics, space and time are treated as separate entities. However, the development of Einstein's theory of relativity introduced the model of space-time, a four-dimensional continuum integrating three spatial dimensions with one temporal dimension. This unification reflects the interdependence of spatial and temporal coordinates in describing the motion of objects and the propagation of forces. Nonetheless, the temporal dimension differs fundamentally from spatial dimensions in its properties and constraints. Spatial dimensions permit bidirectional movement and do not impose an intrinsic orientation. Temporal progression, by contrast, exhibits an apparent unidirectionality, often referred to as the arrow of time, associated with the increase of entropy, as described by the second law of thermodynamics. Moreover, while spatial displacement can be controlled and reversed within certain limits, the temporal dimension does not afford comparable agency. Human experience of time is linear and asymmetrical. Efforts to conceptualize bidirectional or multidirectional time remain speculative and are not empirically substantiated within current physical theories. When discussing higher spatial dimensions beyond the three observable ones, it is essential to distinguish these from temporal dimensions. A fourth spatial dimension implies an additional axis of movement or extension within the domain of space itself, independent of temporal flow. Such a dimension, if it exists, would not represent a temporal coordinate, but an entirely new mode of spatial relation. Certain advanced physical models, including some variations of string theory and M-theory, posit the existence of multiple spatial dimensions beyond the familiar three. These dimensions are often theorized to be compactified or inaccessible at observable scales. While these models expand the mathematical landscape of physical law, they do not reassign the temporal dimension to the status of a spatial one. In the context of the present exploration, it is the fourth spatial dimension that is under consideration. The experience of this dimension would differ categorically from temporal progression. It would entail a transformation in the perception and organization of spatial relations, not a modification of temporal experience. To imagine the phenomenology of existing within such a spatial framework requires disengaging from intuitive associations with time. The fourth spatial dimension, if encountered, would represent not an extension of temporal movement but an expansion of spatial ontology, introducing relational possibilities beyond the scope of three-dimensional cognition. The geometric implications of a fourth spatial dimension extend beyond mere abstraction, challenging the foundational assumptions of form, boundary, and relational structure that underpin three-dimensional existence. In three dimensions, geometric figures and physical objects are defined by measurable properties: length, width, and depth. These parameters establish volume and allow for the articulation of shape, orientation, and interaction. Every object's surface delineates the boundary between itself and the surrounding space, facilitating the organization of matter and the predictability of physical behavior. When extended into a fourth spatial dimension, these principles undergo a profound transformation. Shapes familiar to three-dimensional cognition acquire higher dimensional analogues, with properties that defy conventional intuition. The hypercube, or tesseract, serves as a principal exemplar. Mathematically, a tesseract is to the cube as the cube is to the square. Its properties can be rigorously defined within the language of linear algebra and multidimensional geometry. Yet, while its structure can be projected into 3 dimensions for purposes of visualization, the actual spatial reality of a hypercube eludes direct representation. Its true form exists outside the perceptual capacities inherent to 3-dimensional organisms. The projection of higher dimensional objects into lower dimensional spaces results in significant distortions and reductions of complexity. This phenomenon is not hypothetical but observable even within the transition from 3 to 2 dimensions. A 3-dimensional sphere passing through a 2-dimensional plane manifests not as a coherent volume but as a series of 2-dimensional cross-sections, circles of varying diameters. By analogy, a 4-dimensional object intersecting 3-dimensional space would present as a sequence of 3-dimensional cross-sections, continuously altering in shape and volume. Such manifestations would likely appear inexplicable or anomalous to 3-dimensional observers, lacking any coherent precedent in familiar physical interactions. Furthermore, spatial relationships fundamental to 3-dimensional geometry would become fluid or discontinuous in higher dimensions. The separation between interior and exterior, the impenetrability of solid objects, and the fixed adjacency of surfaces are properties emergent from 3-dimensional spatial constraints. In a 4th spatial dimension, these constraints would no longer apply. An object perceived as bounded and discrete within 3 dimensions could, in a higher dimensional context, be permeated, reoriented, or reconfigured without violating the principles of higher dimensional geometry. The implications for material structure and spatial organization would be profound, rendering the physical laws governing 3-dimensional interaction either obsolete or subject to extensive modification. Thus, the geometry of the 4th spatial dimension not only challenges perceptual assumptions, but also compels a re-evaluation of the ontological status of shape, structure, and spatial coherence. It invites a recognition that the stability and intelligibility of the 3-dimensional world are contingent upon the dimensional framework within which cognition itself has evolved. The transition to a 4th spatial dimension implicates not only the structure of external reality, but also the fundamental constructs of selfhood and identity. The continuity of the self, as commonly understood, arises from the persistent organization of neural processes, memory consolidation, and the stable integration of sensory input within a 3-dimensional spatial and temporal context. These foundations are not incidental, but intrinsic to the emergence and maintenance of personal identity. Human consciousness operates through patterns of recognition, spatial orientation, and temporal sequencing. The stability of self-awareness depends upon predictable environmental interactions and the coherence of bodily integrity within 3-dimensional space. In a higher dimensional environment, these stabilizing factors would be subject to radical alteration or disintegration. The human form, conditioned by 3-dimensional biology, would either fail to maintain its structural coherence or would be reconstituted according to higher dimensional principles inaccessible to prior understanding. The perceptual boundaries that delineate self from environment, boundaries that define the subject-object dichotomy, would lose their operational significance. Moreover, memory as a function of both neurological encoding and experiential continuity would encounter profound challenges. Memory traces are formed relative to spatial locations, sequences of events, and bodily states. If spatial relationships became non-linear or multidimensional in ways that defy 3-dimensional sequencing, the very basis of autobiographical memory would become fragmented or restructured beyond recognition. The persistence of identity presupposes the consistency of spatial and temporal orientation. The disruption of these orientations would not merely introduce confusion or disorientation, it would represent an ontological shift in the mode of being itself. The self would cease to function as a coherent narrative entity, and might instead manifest as a distributed or redefined phenomenon in alignment with higher dimensional relational structures. It is important to emphasize that such a transformation would not equate to an expansion of consciousness in the metaphorical or experiential sense often invoked in popular discourse. Rather, it would entail a categorical redefinition of what consciousness and identity mean within the framework of a reality no longer constrained by three-dimensional parameters. The theoretical consideration of selfhood within a fourth spatial dimension thus transcends psychological and neurological paradigms. It enters a domain where identity is no longer grounded in the continuity of experience or the integrity of form, but is instead contingent upon principles that remain beyond the reach of current cognitive science and phenomenological analysis. In contemplating the dimensional shift, one must therefore acknowledge not only the limitations of human perception, but also the provisional nature of the self as it has been historically and biologically constructed. Theoretical exploration of higher dimensions often assumes, either implicitly or explicitly, the possibility of return. That is, the capacity for an entity or observer to re-enter the originating dimensional framework after a transition to a higher dimensional state. This presumption, while facilitating thought experiments, does not withstand rigorous ontological scrutiny. The concept of return presupposes the persistence of spatial, temporal, and structural parameters consistent across dimensional frameworks. However, a transition into a fourth spatial dimension would entail a comprehensive reconfiguration of those very parameters. The relational structures that define locality, orientation, and identity within three-dimensional space would not necessarily correspond to or be recoverable from the higher dimensional context. The notion of retracing a path through dimensional strata assumes a continuity of movement and positional reference that may be inapplicable or incoherent beyond three dimensions. In three-dimensional space, motion and location are defined relative to fixed coordinates and measurable distances. In a fourth spatial dimension, these reference points would either be subsumed into a more complex relational matrix or dissolved entirely. Furthermore, the phenomenological transformation discussed previously suggests that the self, should it persist, would undergo an ontological shift incompatible with its former state. Memory, perception, and bodily integrity, all constructs essential to the continuity required for return, would either be absent or fundamentally altered. Even if a reversion to three-dimensional space were physically possible, the entity undertaking such a passage might no longer correspond to its previous identity in any meaningful sense. This leads to a deeper conceptual impasse. The desire for return reflects an assumption of dimensional hierarchy and reversibility. Yet if higher dimensional realities operate according to principles beyond three-dimensional causality and coherence, such assumptions may have no applicability. Thus, the exploration concludes not with the closure of the inquiry, but with the recognition of its provisional and open-ended nature. The true shape of reality, should it encompass dimensions beyond human perception, may remain inherently inaccessible, not due to deficiencies in reasoning or imagination, but because the very constructs of understanding and identity are themselves products of dimensional limitation.